Okay, so this is part 3 of our Solid Edge ST4 online training. Again, this is for people who have joined us on the 45-day Solid Edge trial or who are currently evaluating Solid Edge or just getting their feet wet with the program. Today we're going to be looking at building assemblies in Solid Edge. And for those of you who have a Getting Started guide, that's basically section 2 of the Getting Started guide. So that's like pages 2/1 to 2/69. So I'm going to start by going through the exercise. And again, if you don't have a Getting Started guide, here on the Solid Edge welcome screen you can access the electronic version of the guide. And the exercise we're doing today is the assembly modeling exercise. Again, we're progressing in our design of a micrometer. For those of you who were with us last week or who saw the replay from lesson 2, we designed the frame of the micrometer in the Solid Edge part environment. Now we're going to take that frame and build an assembly around it to get the full thing. After that, we're going to create an exploded view and then a top-level assembly drawing. And this top-level assembly drawing will be a 2D drawing that will have the assembly view in there as well as a top-level bill of materials. And this is very important for how to communicate your designs to an external source or to a manufacturer or to a customer, etc. So here we are in the Solid Edge environment, and we've already got an assembly started for us. So I'm going to go into the Open command, which again is in your application button up here. And where you're going to go to, you want to be in, and I'll just expand this so you guys can see exactly where we are with my magnifying glass. We want to be under C prompt, Program Files, Solid Edge ST4 in the training directory. Now, the only time this will differ is if you are running a 64-bit system with a 32-bit Solid Edge installed, in which case the Solid Edge directory will be in Program Files x86. For those of you wondering, Solid Edge is available in 64-bit version, but the trial discs, I think, are only, if you got a trial disc from one of our events, they're only 32-bit. So find that Solid Edge ST4 directory, and we're in the training directory. So there's a lot of files in this directory, as you can see. To kind of clear things down, I'm going to go and I'm only going to show assembly documents. And what we're looking for is we're looking for an assembly, and it's got a really weird name. I'll just find it here. It's STOABMM. You don't want to get the one below it, but use the preview pane to navigate to make sure you've got the right one. You can see that it's an assembly that just has that frame element and this little piece here, the anvil, in it. So that's the one that we want. Now before I hit open, I am going to apply an activation override. And what activation means is this is a tool for very large assemblies. Sometimes you want to see the parts, but you don't want them loaded into memory because every piece of 3D data takes up resources. So to inactivate parts would mean that everything is inactive, therefore not loaded into memory, and you can kind of select the parts you want to work on. This is a very small assembly, so I'm going to activate everything. And I'm going to hit open. Okay, so here we are in the assembly environment, and let's take a look at what we've got before us. Obviously, in our 3D space, we can see the beginning of our assembly. There's the very familiar frame we designed last week. This isn't specifically the file, and you can see that this has been refined a little more. They've put some rads on the corners. They've put some mounting holes on the side, and then we also have the what's called the anvil, and this is if you've ever used a micrometer, this is the piece that sits here for precise measurements. It's a precision machined piece. So we've got that in our design here. Now, taking a look at our environment, what I want to draw your attention to is the pathfinder, which should be kind of to the left-hand side of your screen. It may be somewhere else depending on if you've customized your interface. If it's not shown, there is a way to show it, which is detailed in the manual. But what the pathfinder tells us is the contents of our assembly. So you see here that I have two parts, the frame and the anvil. And as I kind of mouse over them, they'll highlight in the graphical space. Similarly, clicking on them will highlight it green, showing that it's selected. So let me use my box zoom, and we'll just go in here and see that here I have the anvil selected. It's lit up in the assembly tree. Kind of behind my assembly tree, are my two buttons that you'll always have active when you select a part in an assembly. And basically they're asking you if you want to edit the definition, which is the assembly relationships, or actually go in and edit the part, change what that part looks like. So the second one's straightforward because we've already been in the part environment. We know what it looks like to build and edit a part. The edit definition refers to the assembly relationships. So what is an assembly relationship? Basically, for the program to know where things lie in space, it needs to have instructions on how these parts relate to one another. So if we highlight that anvil again and look down here, we're going to see two icons. And what these are is these are the relationships on the icons. And if I kind of highlight the first one, you see that we've got, what it's telling us is I've got two faces lined up. That little icon next to, I've got to find it with my magnifying glass here, but that little icon next to the assembly relationship tells us that that's a mate. Those are two faces mated together, and basically it's that shoulder of the anvil and the leading face of that frame there. They're both highlighted. This symbol is an axial relationship, meaning two cylindrical features are lined up so that their centers are concentric. That's what that means. And that is sort of the shaft of the anvil inside the hole that we put in the frame. So those two relationships are enough to fully define this part's location in space relative to the frame. And that's kind of how things work in the assembly environment. You bring a new part in, and then you build assembly relationships to tell the program where this sits in space relative to the other parts. So we're going to see that in action as I zoom out because we're going to bring in another part. So before we get started on that, I just want to show you that these little check boxes next to our parts in our Pathfinder allow us to turn their displays on and off. So I can uncheck that and my anvil disappears. I can check it again to bring it back. Similarly, like every environment in Solid Edge, we have a central coordinate system, which you can see is that little colored triad there, and also reference planes, which I can turn on and off. And basically, the reference planes and the coordinate system are just kind of your 0 points in 3D space. So I'm going to actually turn off that coordinate system because I don't need to see that. So I'll just click that box there and uncheck it. Now, let's bring in a new part. And what we're going to do is we're going to find the Parts Library tab. It's kind of hiding over here, and as I mouse over it, it'll kind of slide out. If we want, I'm going to expand that a little bit. And if we want, we can pin that down so that it stays there. I've got it auto hidden right now, but if I pin it, that window will stay there. So again, if you can't see this, any one of these down arrows, you should be able to activate Parts Library to display it. And what this is it's basically a directory we can browse through to bring in other parts. So depending on where you are, you might be on, for example, desktop. You can browse down to the C drive, program files, or program x86. Solid Edge ST4 training directory. That's where we want to be. Another fast way to get there, because our assembly already came from that directory, if you click anywhere in this white area to kind of activate the window and hit Control and period at the same time, that will jump you to the directory that the assembly currently resides in. And that just so happens to be the directory where the rest of our parts are. So we got a lot of parts in here, and you see as I click them, it'll give us previews. We got all sorts of different parts. What I'm looking for is a part called nameplate. There's a nameplate that we're going to bring in, and we're going to mount to the face of this frame. So I'll scroll down until I find nameplate, and there it is right there. You see I can highlight it, and I have that preview. Now I'm going to just click and hold and drag that part into the 3D environment, and you can see that it gives me an indicator on my cursor that I'm going to add a part to this assembly. So I'll kind of bring my cursor to where I want this to go and release, and that'll drop that part in my assembly. Okay, a couple things to take note here. The part is kind of this translucent green color, and we have this ribbon bar along the top, and that's because it's jumped us into the creating assembly relationships mode. We're going to create enough relationships until this is fully defined in 3D space. Note also that I'm not getting things showing up in my magnifying glass here, but our parts list has now, our Pathfinder has added the nameplate, but if you look really closely, you'll see it kind of has wiggly lines next to this icon. And what that means is currently it's unconstrained. It's just kind of sitting in 3D space, not really anchored to anything. This ribbon bar here is what will allow us to create the relationships. And there's not a lot of detail we need to go into here, except that it says right now that we are creating relationship 1 right there. And it also shows us the type of relationships that we're creating. If I expand this down, you see that we have all these different types of relationships we can make, axial lines, parallel relationships, lots of different ways to define parts in a 3D space. I'm going to keep it on flash fit because what we're going to see that does is it will infer the relationship type based on the geometry you select. So again, I want to mount the back plate face of this nameplate to the front face of my anvil. So to select that backplate, you notice that as I mouse over these faces and edges, they'll kind of highlight as I bring my mouse around. I want that back face, and you see by default it's going to highlight the front face. Now I can rotate my view so that I'm looking at that back face and it's easier to select, or I can leave my cursor still for a second, and you see I get that little dot, 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 and a right mouse icon in front of it. That's the quick pick, and that's a great way to kind of select geometry that you may not be looking directly at. So if I right-click when it prompts me to, you see that it's going to give me two options. It says, in your line of sight where your mouse is, these are the two faces that you can click on. And I can kind of cycle through them, and I want to click that back face. So now that back face is highlighted green, and my prompt bar at the bottom is asking me to click on a target element. So where do I want to stick this face to? And that's the one right there on the front frame. So I'm going to click that, and you can see it's moved the part to stick it up against that face. So that's part way of where I want to be, but that's not entirely constrained yet. Notice on the bar now we are ready to create relationship 2. I'm still not fully constrained. I still have wiggly lines next to my nameplate icon in my Pathfinder, so it needs more information to fully define where this nameplate is. Now what I'm going to do is, if you think about it, well, we've got these two bolt holes here, and we've got two holes on the frame. So let's line those up. And to do that, I'm going to go in and select that hole there, not the edge, but the whole hole. Again, if I have trouble selecting that, I can wait for quick pick to come up, right-click, and cycle through the different faces I can select. And it's that I want. And then I'm going to find the bolt hole in the frame and click on that. And notice it's gone and lined it up. Now, it actually looks like it's in the right place to me, but Solid Edge is telling me that I still need one relationship to fully define this in space. And that's because if you think about it, the face is connected, the back of this plate is connected to the face of the frame. One bolt hole is added up, but this is actually free to kind of rotate around in space. So to completely define it, let's click on that other bolt hole, like that, and then find the bolt hole in the frame. Now, notice that my toolbar went away. My part colors are showing, and the wiggly lines are gone in my Pathfinder. That tells me that it's fully constrained. So we've placed that completely in 3D space. Let's keep going. I want to put some screws into this to hold this in place. So I'm looking for a screw. And another way you can kind of quickly browse through this if you know the file name is just highlight something, and then just like in Windows Explorer, click the first couple of letters, and it will jump you to that file. So there it is. It's screw 1 that I want. And again, I'm going to click and drag that and just let it go in 3D space. So, bit of a shortcut here when you're inserting fasteners is to try to grab the edge of the fastener. So we don't want that face. What we want is the edge. And I'll just turn on my magnifying glass so you can see. I'll let Quick Pick come up. And then when I right-click, you see that it's this edge that we're after. So by selecting this edge, and then I'll select the edge on the nameplate, it'll quickly insert that fastener. It's sort of a shortcut that Solid Edge has built in for inserting fasteners. So I've got one of my screws in. I'm ready for another one. I can, again, pull it out from my Pathfinder or from my parts library, but I can also just grab the entry in the Pathfinder, click and hold, and that's another way of adding another occurrence of the same part. So if I release it there, it's placed that in 3D space. Now, same drill as before. I want to find that leading edge. There it is right there. And I want to select the outer edge of the bolt hole. And that will insert the fastener. Okay, so you see that our Pathfinder is growing as we add more parts to our list. The last thing we're going to add is the whole spindle assembly. This is the part you actually twist to move the micrometer. And this is, instead of this being a part, it's actually a sub-assembly. So it's already an assembled collection of parts, but we're adding it in as a sub-assembly. So I'm going to find, I think it's called spindle sub. There it is there, spindle sub 1. I can see in my preview that that's what I want. So I'm going to click and drag. And I'll kind of bring my mouse over here and drop that into space. Okay, so what I want is there's a leading flat face. If I rotate this around, it's that face right there that I want to line up with this face. I want to press it up against this face on the frame. So to do that, again, I can rotate my view, or I can kind of mouse over behind that face, wait for Quick Pick to come up, and grab that leading face. And then grab this one here, and that'll set that face up against that. Now, that's good, except that I need to line up the shaft of my spindle with the hole in my frame, so I'll click those two and line it up. Now, at this point, it's telling me it needs another relationship. It's free to rotate. I don't really care what the rotation is. It's not really relevant to me, especially since this is a rotating part. So I'm just going to lock that rotation. And what that does is it says, just leave that wherever it is right now, because we don't really care where it's rotating. So you can see I'm fully defined and my spindle's in place. Let's change my view to a trimetric view just to get a bit of a better view. And I'm also going to go into the view command and just turn on this nice floor reflection. There's no real need to put a floor reflection down. It just kind of looks cool. And I'll also unpin my parts library so that it slides back in here as a tab, just to give me a little bit more design space. Okay, so a couple of things to note. We can click on any of these parts, like the nameplate, and view the relationships. So remember, there's those three relationships we created when we placed the nameplate. We've got the faces mounted to each other, and we've got two holes lined up. And similarly, it'll show us all the dependent relationships. Here's two relationships for each of those screws when we inserted them. I can click on any one of those relationships and adjust it. For example, a mate relationship where you've got face-to-face, you can key in an offset down here. So if I say give me a 20 mil offset and hit enter, it'll put in a 20 mil offset. And notice that it's carried the screws along with it. So that's one way we can kind of change how things work. Things don't have to be mated face-to-face. They can be lined up but then offset to one another. I'll just hit undo up here to undo that. Another way we can move things is with the steering wheel. You notice that any time I click on a part, I get the steering wheel that'll come up. And it'll kind of be on the part at some point. Now what you can do with the steering wheel, just like we used it to modify a part in the part environment, you can use it to move parts in the assembly. So what I might want to do is direct the arrow to where I want to go. And to do that, I'll just put my magnifying glass on here. You see that my major axis is pointed not in the right way. I want to pull this out from the face. So I'm going to click on this little node to switch the direction of the arrow. And then when I click the arrow once, it'll start a move command. Now notice the difference between moving something with the steering wheel is that it doesn't necessarily take the relationships with it. So I'll put in 20 mil, for example, and then it's going to tell me that I've violated some relationships. What do I want to do? And in this case, I'm going to select adjust the offset. So by hitting OK and looking at that nameplate again, you can see that it's keyed in a 20 mil offset from that face for me. So different ways to move things in the assembly. You can either use the steering wheel or adjust offsets within the assembly relationships. Again, I'll hit undo to bring that back. What about modifying parts? What if now my engineering manager comes up to me and says, we need 6 millimeters more depth in this frame. In effect, this whole jointed system has to come up 6 millimeters. So I got two ways I can do that. I can click on the frame because I know that's the part that I need to modify to achieve that change, and I can click the Edit in Place, which will take me into the part environment, and I can edit it much the same way we edited our part in last week's lesson. The other way I can do that is do the edit right from the assembly environment, and the way I'll do that is I'm going to go up here to my Select tool, and I'm going to click the little down arrow below it. And from there you see that I've got these two selections, face priority and part priority. Right now it's set to part priority, and what that means is that if I click on anything, it will select the entire part within the assembly. Face priority, on the other hand, will allow me to pick up on a face. So if I change my priority to face priority, notice now as I mouse over, it's actually picking up on faces, flat faces, round faces. What I want to do is I want to grab this face here because that's what I want to move up. And I'll just zoom in so we can see what we're doing a little bit better. You see that I do have a steering wheel that's already by default in the center of that, and my major axis is pointed in the right way. Again, if you get something like this where your steering wheel is in the wrong direction, just use these little control nodes to snap it 90 degrees from where it was. So now my steering wheel is pointing straight up. I'm going to click that arrow to start the move. And let's take a look and see what happens. Okay, so right now Live Rules has detected that the two cylindrical elements are in line with each other, and those two elements I mean are sort of the small end where the anvil mounts in and the larger end on the right hand side where our spindle mounts. They're lined up and it's saying, well, I want to maintain that alignment, and that is in fact what I want to do. Also, assembly relationships on the anvil and on the spindle are carrying those parts along for the ride. So at this point, I just want to kind of move up from where I originally am, and you can see my original position is kind of in gray there. So I want to move up from that and then key in 6 millimeters because that's my new offset. And it will go and modify the part, keeping my design intent. It's precisely modified that to be 6 millimeters higher, and my assembly relationships have carried on the adjacent parts along for the ride. So you can see that in Solid Edge you can make these changes to an assembly without even leaving the assembly environment. And it really is as easy as clicking on a face and moving it with the steering wheel. I'm going to go back after this and show some more examples of that. But right now let's go and make an exploded view. So before I go any farther, I'll just hit Save to save my assembly. And let's go and create an exploded view. So to create exploded views, you want to find the Explode, Render, Animate button in the Tools tab. It's right here. And that will take us into the environment in the assembly where we can create rendered views, exploded views, even animations. So I'll just zoom out a bit and pan down so we can see what we're doing. And the command I'm looking for is Auto Explode. Exploding an assembly is very straightforward if you use Auto Explode. Basically, we start that command. Here's our toolbar of options. So we can decide if we want to explode it at the top level assembly or explode one of the sub-assemblies. I'm going to click the top level and hit check. Now we have some options. Like many things in Solid Edge, you have an option button, and clicking on that will give me a few more options. Binding sub-assemblies means when it explodes it'll keep the sub-assembly all together. I'm going to uncheck that because I want to see all the parts of the spindle come apart. We can also go with the default spread distance or key in our own. I'm going to keep it at 10 millimeters. We'll hit explode, and all of our parts will explode for us. Pretty straightforward. What we're doing is we're trying to create an exploded view that we can use in documentation or drawings that'll help people assemble this. You know, like when you buy IKEA furniture or something. So that looks good. Maybe what I want to do now is make it a little more concise. It's a very long view. Maybe we can kind of change the positioning of parts. And I'm going to use the reposition the drag component command. So by starting that command, it's going to prompt me to click on a part. And again, I have some options here. Really the most relevant is whether I want to just move the part, the selected part, or move all its dependent parts. And when I click on this part of the spindle here, you'll see what I mean. I've clicked on that, and it will pick up anything that comes after it in the explosion, which is what I want. Now I've got it set to a linear move so that when I hit check mark, we're going to get this triad, which is sort of the 3 directions I can move this. I'll click once to select the Z axis, which is up and down, and then I'm just going to click anywhere and drag. And what that's going to do is that's going to pull that down, and I can key in a distance where I can just kind of eyeball it. And notice that my jog lines will update. Now I'm going to bring it over by selecting the X axis and again clicking and dragging, and just kind of bring it over maybe there. And you see that my explode lines have updated. Now the lines themselves aren't doing exactly what I want, so I'm going to go immediately into the modify. And this modify command modifies our explosion line. So I'm going to start by clicking on the one line here, and it's going to give me this little arrow. Clicking once on that arrow will allow me to drag that line back and just kind of have a little bit more control about how this is displayed. Let's do the same thing with this line over here because it's kind of colliding with the frame. So I'll click that once. There's my little move arrow and drag that back. Okay, so that's kind of how I want this exploded view to look. The last thing I'm going to do is I'm going to save this view because I've put some work into how I want it shown. So to do that, I'm going to go into the Display Configuration tab, and I want to create a new display configuration. So I'll click that, and I'll call it Explode 1. Okay. And there it is saved. So now with that saved, I can unexplode my view, and if ever I want to see that again, I can just pick that Explode 1 from the drop-down menu to return to it. So let's get out of Explode Render Animate, and I'll use the Fit to Screen command down here to fit that into view, and then save my part, or my assembly rather. Okay. Last thing I want to do is I want to review the physical properties of this. What are each of these parts made of? And there's a great command in here called Property Manager. Now, I don't know where that is, so I'm going to click in the command finder and just type property. Again, I'm showing you guys this because this is a really handy tool to use if you're just getting to know the interface. So I've typed property in there. I'm going to hit enter, and it's going to show me any command that has the word property in it. And there right at the top is the one I'm looking for, the Property Manager. So if I mouse over that, it's going to show me where in the interface that command is hiding, or I can just click directly on it to start the command. And the Property Manager will bring up this kind of spreadsheet view of all the parts in my assembly with a bunch of information about them, things like their document numbers, materials. If you want, you can add more columns by right-clicking on the column section here and selecting columns. And then you can check to bring in all sorts of more attributes, things like author, when it was last saved, when it was created. Lots of ways to review this. I've got material selected, and I may want to even drag its position up here so it's front and center. And what I want to do is I want to change the material of the spindle part, which you see I get a preview when I click on it. Right now it's aluminum. I'm going to highlight that, and from the drop-down menu, pick a new material. And these materials are all defined by myself. Solid Edge comes with a library of materials, but as you design, you can add more to it and kind of build up a library of materials you use. So I'm going to change this from aluminum to stainless steel 303 and hit OK. And that's going to update the physical properties of that part right from the assembly environment. All right, let's go and make a drawing of this assembly because we want to show that exploded view and that top level assembly drawing. So to do that, I'm going to go in and create new, and we've done this before. Again, we can start a new draft and then bring this in, or we can use this shortcut which is called create drawing, and that again makes a drawing from the open model. So it has asked me to pick a template, and just like we did in the part training, I'm going to use a quick sheet. So I'm going to go into my quick sheet tab here and find the test drive ASM quick sheet. Now again, a quick sheet is a draft file that basically remembers view orientations, fonts, and settings so that you can rapidly create drawings of similar layout. In this case, my test drive ASM quick sheet is going to be looking for an exploded view called Explode 1. So I'll click OK. You want to make sure that the Drawing View Wizard is not checked because we already have all of our settings in this quick sheet. So I'll hit OK, and there, if I fit to page, you see that it's brought in that exploded view that we created earlier, and then it's even rendered it. So this is the type of information a quick sheet remembers, so that it's a very rapid way to get information into a 2D space. Now it is giving me these lines, and what that's telling is it's just saying that my assembly hasn't been saved. So I'll just switch windows back into the assembly, and I'll go up and save that again. All right, let's go back into that draft. So it's prompting me to update the views, and I'll do that. So we've got a nice exploded view here. What I want now is a parts list. So to do that, I'm going to start the parts list command, which is right up here on the main home tab. I'll click parts list, and it's asking me down here in my prompt bar to click on a drawing view. This is the drawing view that the parts list is going to be based off of. Oh, just to go back a step, when you use the quick sheet, if you don't see this exploded view, it's just because you named your exploded view something other than explode 1, which is what it's looking for. So you can actually start up the drawing view wizard right up here, and selecting that top level assembly, you can then go in right on this first screen and pick that exploded view right from the list. So again, if you don't get your exploded view from the quick sheet, it just means you've named it something other than explode 1, which is what the quick sheet is looking for. Start up the drawing view wizard and select it from this tab in the very first window and hit finish. So back to that parts list. I'm going to start the parts list command, click on my drawing view, and I'm just going to go into the options here, and there's a lot of ways we can configure our parts list. We can determine what type of information it's going to show in the parts list, how the columns are merged and set up. In this case, I want to go to list control, and I want to change it from a top level list, which will only show me the top level components and subassemblies. I want to change that to an atomic list. And you see what that's going to do is that's going to include all the subcomponents of my spindle subassembly, and that's what I want. I'm also going to go to balloon and turn off that I don't want to show my item counts in my parts list balloons. You're going to see that this will automatically put balloons to indicate which part is which number in the parts list, and I just want it to show the item number, not the item count. So I'll hit OK. The parts list is on the end of my cursor, and I'm going to place it right in the corner here. Okay, so let's use a zoom tool, which I have on my radial menu, to just zoom in here and take a look at our parts list. So you see there's item number, they've given us our document number, the title, the material, as well as the quantity of each of them. If I pan over, we can see that all of those parts have been numbered. Alright, so we got a pretty nice looking drawing here. Now this is where I kind of stray from the test drive script and just show you guys a little bit of extra things that you can do over here. Let's look again at modifying assemblies and parts in the assembly environment. Let's say that my manager tells me that we want this nameplate to line up with the very edge of these radius here. We want that to be lined up. Now if you think about that, well, to do that, I'm not going to change the size of the nameplate. He says move the holes, the mounting holes, such that the nameplate lines up with the top edge. So you got to think about that. Well, we need to know how far we have to move those holes so that the nameplate sits aligned with that edge. So here's how we do that in Solid Edge. Remember that if we select a part, we can move it. And what I'm going to do is I'm going to make sure that my selection is set to part priority, so I'm selecting parts. And I'm going to grab the parts that I want to move. And in this case, I'm going to move the nameplate, but I also want to move the two screws. I'll move them up as well because they have to stay centered on the nameplate. So with the nameplate selected, I'm going to hit space, and that's going to give me the little plus or minus symbol on my mouse, which means that I can select other components. So I'll select one screw, two screw. Now you can see that those three components are all highlighted, both in the graphical display as well as over here in the Pathfinder. The next thing I need to do is set the direction of my move. And you see that my steering wheel, I've already got my minor axis pointed in the upwards direction, which is where I want to move. So that works. But because I want to line that top edge up with the edge of those radii, I want to move my steering wheel to that top edge because that's kind of my reference point. So to move your steering wheel, you want to find that center node that I've clicked on here and click it once. That's going to put it on the end of your cursor. Now notice as I bring my steering wheel over various faces, it will kind of snap itself to be in alignment with those faces. If you put it over a cylindrical edge, it'll bring itself to the corner of the cylinder. Unless you pick up on one of these silhouette edges, in which case it'll move itself right to the silhouette edge. So I'm going to kind of move it until it's showing me that that top edge is highlighted, and then I'll click again to place it. Now my steering wheel is on the top edge. What this means is that when I start the move, and you can see my steering wheel moving up and down, I can snap that edge to an adjacent piece of geometry. And the way I'll do that is I'll set my key points to endpoint, and then just down here find that endpoint. You see, as I come up to that where that radius meets, it recognizes that as an endpoint, and it snaps that edge where my steering wheel was set to the endpoint, so I know that they're lined up. I'll click again to accept that. Now it's saying that you may have violated some assembly relationships. I'll say no problem, just adjust the offset. And anything that it cannot adjust an offset to, I will suppress. And the reason that there's some assembly relationships it can't adjust to is that if we spin this around, notice that we've left those holes behind. You can see the two holes in the frame. They didn't come with us. And now our screws are out of alignment. That's the relationships that I've suppressed. I've just said, turn those off for now. We'll deal with them later. So let's deal with those right now. Our frame, or our nameplate, and our screws are now in the right place. All we have to do is change the position of these holes. So to do that, first I'm going to turn off the screws so I don't see them kind of poking through my material. This makes it a little clearer. And I'm going to change my selection to face priority. Now when I mouse over my part, I'm picking up on faces. So what I want to do is I just want to pick up on one of those holes, and it's going to give me my steering wheel with the two arrows, and the up is where I want to go. I want to move this hole up so that it's now in line with the holes in the nameplate, because that should be the new position of these holes. So I'll click on that steering wheel once, and I'll start the move. Now as I click on that, notice what's happening. A couple of things are going on here. The first is that it's bringing the other hole with it, and that's because Live Rule recognizes that those holes have a linear relationship. They're lined up along the same axis. That's good. That's what I want. It's also bringing the edge, the bottom edge of my frame. You can see that that's expanding, and if I zoom out, you'll see why. Somebody has put in, whoever designed this before, has locked a dimension. That 10 mil is pink, meaning it's locked. So for whatever reason, someone has decided that that's a key dimension. They want to keep that 10 mil in between the center of the hole and the bottom edge of the frame. And that's fine with me. I'll let that come along for the ride as we move this hole up. Now the last thing I need to do is find where I'm bringing this to. Where am I locating it? I don't know the distance I have to bring it up. So instead I'm just going to reach down here and change my view style to show the hidden edges. And now, looking through the part, we can see the holes in that nameplate. I want to snap to those holes. Again, if I can't do it, you may want to look up at your key points and set that now to center point, because that'll allow us to snap to the center point of the hole on the nameplate. And then clicking once will accept that. So now that if we zoom in, you can see that those holes are perfectly aligned. And I'll change my display configurations back to show my edges. And you'll see that those are aligned, and if I show my screws, they're lined up. So just to review what we did, we drove the design of a part based on where we wanted things to fit in the assembly. And we did that first by lining this top edge of the nameplate up with the edge of where these radii start. And then once that was in place, we knew where our holes had to move to, and we grabbed the holes in the assembly environment and moved them up to join up. So it's just an example of kind of the dynamic interface you work with in Solid Edge. And it lets you, you realize that we didn't key any measurements or make any measurements in this. The geometry was all there for us. All we did was use our steering wheel to kind of click and drag and snap things together. Going back, I'll save my assembly here. Going back into my drawing using the switch window command, there's my draft right there. It's going to tell me, this gray box tells me that the drawing needs to be updated, and as I update the drawing views, it'll tell me what's changed, and my drawing view will update. So, I'm going to stop the recording now and open it up for questions. Thanks a lot for everyone. Remember that this will be broadcast on a replay so anyone can watch it, and let's start taking some questions now.